Hi everybody, this is Mr. Folly, and welcome to 2.1. Hey, we've got one of these down, we got one of these to go. Well, we got more than one to go, but you get the idea. We're going to do, this is very much a review type thing, where all we're going to do is electron configurations focused on ions. So let's go ahead and get started. I am your host, Mr. Folly, and let's start. All right, ion determination. The periodic table indicates the charges of atoms when they form ions. So the simplest way to do that, I'm going to blow up on this, and you should write this on your periodic table, and probably every periodic table you ever get. +1, +2, +3, 0, -3, -2, -1, 0. So what that means is, if I'm looking at this element right here, its charge is -1. If I'm looking at gallium, it's in the +3 column. When it forms an ion, its charge is +3. If I'm looking at the potassium atom, atoms are neutral. Potassium, when it forms an ion, will always be +1, right? I don't always swing a stick, but when I do, I swing it right-handed, right? I don't always throw a bowling ball, but when I do, I throw it right-handed. So you can't say, look, Mr. Foley's bowling right now when I'm not bowling. Something I say, he's bowling right-handed. Something has to tell you it has a charge, and then the charge will always be that. The ones in here are mysteries. Woo! And really, they have more than one possible ion. Okay? The periodic table indicates the charge of the atoms when they form ions. Positive ions lose electrons. +2 means lose 2. Negative ions gain electrons. -3 means gain 3 electrons. Ion configuration steps. Determine the number of electrons. You have to add or subtract it. And then what is it isoelectric with? What isoelectronic means is same, excuse me, electron configuration. It will be with a noble gas, okay, for these ions. So if I'm looking at calcium, calcium is number 20. I'll highlight here. Calcium is number 20. Calcium +2 means it loses 2 electrons, and it's number 18. So it's going to have the same valence shell, same electron configuration as argon. So then I'm just going to do the electron configuration like we did before. So it's isoelectronic with argon. Oops. Let's see if I can get it again. So I'm going to get 1s2, 2s2. Oh, come on, you can write. I'll slow down a little before you then. All right, computer glitch on my end. So I'm going to start the calcium +2 again will be like argon. 1s2, 2s2, 2p6, 3s2, 3p6. Noble gases will most typically end in 3p6, except for helium. That's it. That means it's exactly the same. All right, n-3. So n-3 means I'm going to add 3 electrons. Nitrogen has 7, 8, 9, 10. This is going to be like the noble gas neon. It doesn't become neon. It just becomes like neon. 1s2, 2s2, 2p6. All right. Orbital diagrams help show what it takes to fill an energy level and determine the charge. O is -2 because it takes 2 electrons to fill. Remember how we talked about it being filled is so important? The second energy level, full S&P. Titanium is +2 to empty the 4th shell, which means the 3rd shell will be full for S&P. Or it'll be +4 to empty the 4th and fill the 3rd. Lithium is +1 because it loses 1. So let's take a look at these. So if I've got oxygen, oxygen's orbital diagram to start with is 1s2, 2s2, 2p4. Okay, so oxygen wants to be full. In order to fill it up, I'm going to change to a different color here. In order to fill it up, I would add 2 electrons, and then that would give me a full 2p. So that's why it's O -2. I added 2 electrons. Okay. Titanium is 1s2. Didn't do that on it. 2s2, 2p6, 3s2, 3p6, 3d. Whoops, I'm missing 4s2. 4s up, down. 3d2. Okay, so that's titanium. Now, titanium, again, wants to be full or empty. So if I want my 4th shell to be empty, I could lose 2 electrons, and then it would be I would get rid of these. These would go away. And if I did that, I would be Ti plus 2. The other thing that titanium can do, so remember titanium's in that D block, we didn't say it doesn't always charge. It could lose 4. Because if it loses these and these, then I've got a super full P level, right? Which S and P are the valence electrons we care about. So it loses 4, it also forms titanium plus 4. Okay, so what do you lose? You lose valence electrons, outer S and P, lose, add, outer S and P, and then sometimes D. Okay, all right. Lithium is 1s2, 2s1. Okay, so lithium would have to add 7 to fill this up. No, that's too hard to do. So it's going to lose 1 electron. So this one right here will be erased. And it will become, lithium will just be 1s. That's it when it forms the Li positive. All right. I do. So show the electron configuration of each atom or ion. So here's barium plus 2. Ugh, barium. So barium has 56 electrons. It's a big dog. So I'm going to do all of barium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. I almost caught me sleeping there. 5. Let's see, where's barium? Barium's on the 6th level. 5p. Whoops, not 5p. I'm at 5s. 5s2, 4d10, 5p6, 6s2. Now this is barium. Ba plus 2 loses 2 electrons. So it's going to be the exact same thing as this, but I'm just going to cross that off. Okay? So I guess I'll write it down again just for kicks and grins. 1s2, 2s2, 2p6, 3s2, 3p6. Hello, 4s2. How's it going? Good, good, good. I'm in the middle of an electron configuration, so I'm almost done. I know. P6, 5s2, 4d10, 5p6, and that's my final answer. So that's it. Not too new, not too crazy, but lots of fun. Toodles.